There we go. Okay, so last class we did do law of sines, just reminding you it's sine of big A over little a, sine of big B over little b, and then sine of big C over little c. The big letters, excuse me, are the angles, and the little ones are the sides. Okay, so I'll keep that up for right now. I might get rid of it when I decide I want to do calculator stuff. But let's see. Okay, I think all we did were 2 word problems and then, or 3 word problems and then 2 law of cosine. So actually we're in a good space. Okay, let's see, I want to clear that page and I want to clear this page. So what we did the other day is we learned how to use just law of sines. And I will give you a normal law of sines on the quiz. I'm not going to do the ambiguous case. That will be very obvious when I do that. I'll ask you how many triangles there are. I just want you to do a normal law of sines. So we practiced this out. We did 3 problems that were very normal law of sines. We found the missing angle. We found both missing sides. We drew pictures if we needed to, all that fun stuff. The second thing we did last class was that we learned about the ambiguous case, which is anytime I give you angle and then 2 sides, angle, side, side. We could have 0 triangles that are true there. We could have 1 triangle that's true, or we could have 2 triangles that are true. So we kind of worked out those examples. So if you are not familiar with this, I would go back and look at this one more time. And then today we're doing a very similar thing, but this time we are using the word problems and we're solving that way. So these first 2 problems, and actually I'm going to go a little out of order. Let's do number 5 first. I think it's the easier one. So we're going to do number 5. Okay, so this one says 2 lighthouses, lighthouse A and lighthouse B. So lighthouse A is here and lighthouse B is below it, are known to be exactly 20 miles apart on a north-south line. So one's directly above the other one, 20 miles. A ship's captain at S measures ASB to be 33 degrees. So that's this right here. And then a radio operator at B measures the angle ABS to be 52. Okay, great. We want to find the distance from the ship to each lighthouse. So I essentially need to find little b and I need to find little a. Okay. So we're going to use law of sines here. Yeah, Raven.
On the quiz or test is it going to be 2 parts where it's like the blue paper and the white paper?
I believe it's just 1 part.
Okay.
I was looking at it this weekend and I think it's just 1 part. Good question, Raven. Good question. Okay, so there's a couple things we could do first here. What I am probably going to do first is find missing angle A. And then once I find that, then I can do either big A, or I can either find little a or I can find little b based on the angles that I have. So we know that all of the angles should add up to 180. So I'm going to go to my calculator and do 180 minus 33 minus 52. And that is going to help me find angle big A. Let me find, that is not what I want. Do this. So 180 minus 20. Oh, sorry, no, that's wrong. 180 minus 33 minus 52. That gives me 95. So angle A is 95. And again, now I'm allowed to find either little b or I can find little a. But for both of them, I would use what was already given to me, that angle S is 33 and that across from it, little s, side S is going to be 20. So for both of the equations I set up, I'm going to start with sine of 33 over 20. And for one of that, that's going to equal sine of 95 over little a. And for the other one, I'll just set it up right below it, and then I'll separate them to solve. Sine of 33 over 20, that's going to equal sine of 52 over little b. So you find A and B kind of separate from each other. They do not depend on each other. So I'm going to do both of those equations independently of each other, but I'm using sine 33 and over 20 for both of them. So I'll do this one over here. I'll do this one over here. And then we'll solve. You guys were pretty good at this last week, so I'm just kind of going to solve, and you can watch my work if you want to. I know I've got some weird copier on this paper. Just ignore that. A times sine of 33 equals 20 times sine of 95. All we need to do is divide by sine 33, and I will just go ahead and put that straight in my calculator. And that equals 36.6. I believe that's in miles. Take a second, make sure that you have that. Oh, shoot. All right, same idea for the next part. I'll just go ahead and breeze through that. I hope you guys are already done with the next part. I will just finish solving it. I'm sorry, I got distracted. All right, cross multiply again. B sine 33 equals 20 sine 52 divided by sine 33. And B equals 20 times sine 52 divided by sine of 33. And that is 28.9 miles again. All right, questions or concerns on this part so far? That was a pretty easy one, right? That's exactly what we have been doing, very straightforward. The other two word problems are pretty straightforward too, but they're gonna want us to go one more step extra to find a different side. So we're gonna start kind of here and then move on from there. So anybody questions on this number 5, this last one on the page? Sorry, we went a little out of order. Okay. I'm going to move on. I'm going to go back up to number 3. Number 3 and 4 are super similar, so it really doesn't matter which one I do first. Number 3, though, I think we copied this from the teacher's book because it does tell us what the answer is. This little thing, it says it's approximately 0.7 miles. So we're going to use that to kind of check our work when we're done, make sure that we get the right answer. All right, this situation says observers 2.32 miles apart. So I've got an observer at point A and I've got an observer at point B. See a hot air balloon directly between them, but at the angle of elevation shown in the figure. Find the altitude of the balloon. Okay. So I know I've got angle A, so little bystander A sees this hot air balloon at 28 degrees as an angle of elevation. So it's looking up 28 degrees. We can use that to help us find little a, the side across from it. I also know that observer B sees it at an angle of elevation of 37 degrees, so a little bit more, and I can use that to find the side across from it. Now, I don't have either of those sides, so that means that I need to use the other angle on the other side in order to figure out what either of those two sides are. I know that the side across from the hot air balloon is 2.32, but I don't know the angle. Can I find that angle? Yeah, just minus it from 180, right? 180 minus 28 minus 37. So I get 115. Okay, good. I need 115 because I'm going to use that to set up to find one of the other sides. Now, my end goal is not to find both sides, both distances from the observers to the hot air balloon. My ultimate goal is to find the altitude of the balloon, which is not even shown yet. So what we're going to do is we're going to find either little a or little b, and that's going to help us find the altitude. Do you guys care which one we find? No, truly doesn't matter, right? Let's just find little a because we're across from it, okay? So we're going to do the yellow one. I'll say sine of 115 over 2.32 equals sine of 28 over little a. All right, solve like we have been doing. You guys have been good at this part. A times sine of 115 equals 2.32 sine of 28. Divide by sine 115. And I get A equals 1.2. Okay, cool. All right, 1.2. Okay. Now that's not what we need to find. We have to find the altitude. Do you remember what an altitude is?
So it's that like line like straight from the one, like right where the
Good. It's like the height of my shape. It's essentially how far away from the ground the hot air balloon is. Well, that's all cool because now I've got a little right angle, which means I can make a right triangle here. So if I kind of pull this right triangle out away from my picture, what is the same, what stays is this 1.2 distance as its hypotenuse and my 37 degrees as my angle. Now, I know that I had 115 as that whole angle up top, but I don't really know how much this little angle is. And I know that the bottom was all 2.32, but I don't know how much of that is. I don't really need that though, because I just want to find this height, my altitude. I'm going to label it H for height.
we do know one angle. You can do 37.
Oh, we could. Very true. I forgot. But I don't even care what that angle is. We're just going to use right triangle trig, basic stuff. If this is the angle I gave you, what is 8 or what is H in terms of opposite adjacent hypotenuse? Opposite. What's 1.2? Hypotenuse.
So sine of 37 equals O for H.
Which in this case, what's your O?
X.
Sure, X or H or whatever variable you want. And what's your H? 1.2. Sine of 37 equals my height over my 1.2.
And you just multiply by 1.2. 1.2 sine.
Sometimes we do such harder things that when we get to something like this, you're like, that can't be that easy. It is. And it's 0.7. And that's what they told us the answer was, isn't it? No, they don't always tell you the answer. I just wanted to point out that's what that was. And it is the answer. So it's all good. Okay. All right. Anybody have any questions yet? We're going to do a very similar thing on the next one. So let's go down there. We'll set it up and then I'll have you kind of work it out together by yourself. Okay. So this one says 2 meteorologists are 25 miles apart, located on an east-west road. Okay, so they're straight apart from each other. A meteorologist at point A sights a tornado 38 degrees east of north. Oh, time out. Oh, sorry, I did not mean to be such a big yawn, but really time out. If it says it's 38 degrees east of north, that's not in my triangle. If I have this fake north side right here, we went 38 degrees. It's not an angle of elevation. It's not an angle of depression. It's 38 degrees from north. How much is this angle right here then? -90 minus 38. So that angle is going to be 52. Okay. Similarly, the meteorologist at point B cites the same tornado at 53 degrees west of north. So again, that 53 is not inside my triangle. That 53 is out here. So what's going to be the rest of that shape, the rest of that angle? Mm-hmm. 90 minus 53, which is going to be 37. Okay. Now it says find the distance from each meteorologist to the tornado and find the distance between the tornado and the road. That means we need to find B and A and H. I have to use law of sign for which two of those variables?
A and H, or A and B.
A and B. So I need to use law of sign for both A and for B. And then I can separate the triangle and just look at a little tiny right triangle to find H. Okay, so I'm going to do A and B pretty quickly because we've gotten pretty good at this law of signs. Would you agree? Okay, so I'll set those up. Before I can set it up though, let's figure out what angle C is because I'm going to need to know that. What's angle C going to be? What do you say, Rocco? 91? Awesome. So we know 52 plus 37 plus 91 must add up to 180. So now that helps me find my, use my law of signs. So I'll do sine of 91 over 25 equals sine of 37 over B. And I'll do sine of 91 over 25 equals sine of 52 over little a. So I'll do both of those equations separately. Sorry, forget all my numbers. Sine of 52 over little a. And sine of 91 over 25 equals sine of 37 over little b. So that's what my two equations are going to look like. So we're going to start by solving them. I'll zoom back out in a moment. When I get both my A and B, and then we'll find H, and then we'll be done. Okay, I got 19.7 and about 15. Does that look good to you guys? 19.7 and about 15 for letter B. Anybody have anything different? Okay. All right, so that found A and B. And now it truly doesn't matter which side of the triangle I look at, but I'm going to zoom in on this triangle right here, and I'm either going to look at this left side right here to help me find my height, or I can look at the opposite side to help me find my height. It truly doesn't matter. Just make sure whichever one you use, we are like staying true to what the measurements are. So I'm going to take this side that I already have drawn right here. So I'm going to separate it. I know that this angle, since I took it from the like right side of the shape, That one has the angle of 37. And then it has the hypotenuse of little a, which was 19.7. And then I want to find the height. Which trig function do I use? Sine. We use sine again. My O, my opposite is my H, and my hypotenuse is my 19.7, and I've got my angle. So I'm going to do sine from here. I will do sine of 37 equals H over 19.7. I will multiply by 19.7. And I will put 19.7, whoop, go away. 19.7. If I could get a decimal, that'd be cool. There we go. Times sine of 37, and I'm going to get 11.9. All right. So those were our word problems. Any questions yet? Okay. I want to teach you law of cosines. This will not be on the quiz on Wednesday, but it will be on your test next Wednesday. So we're going to write law of cosines on our identity sheet, and then we're going to do 2 problems practicing it, and then the rest of class will be yours. Okay? Anybody questions yet? All right. So we're going to do 1 and 2 momentarily, or at least A and B. But I want you to jump to your identity sheet first. And next to law of sines, we're going to write law of cosines. Law of cosines. Okay. Law of cosines has 3 equations. They're all technically the same, but they're written just a little bit differently. So I like to show you all 3 versions. Okay. Law of cosines is modeled after like the distance formula. It's modeled after Pythagorean theorem. I don't have time to prove it all the way out, but it starts like this. I've got a squared equals b squared plus c squared minus 2 times b times c times cosine of big A. So one thing I want you to notice is whatever little number or little letter is by itself on the left side has the angle that we're going to do the cosine of. The other 2 angles are being squared and added to each other. It truly doesn't matter which one is B and which one is C because they are commutative. And then B times C times 2, again, also commutative. It doesn't matter which side is which. Okay. I'm going to write this 2 more times, but with B as the number that's by itself and then C as the one that's by itself. So I'll kind of speak it out loud as I write it, and then I'll zoom out so you can read it. B squared equals a squared plus c squared minus 2 times a times c times cosine of big B. And then I've got c squared equals a squared plus b squared minus 2 times a times b times cosine of big C. Again, the side that's by itself, its angle opposited is the one that we're doing the cosine of. And then the other 2 sides, it doesn't matter what order they're in. And that is my law of cosines. Okay. Now, the cool thing about law of cosines is usually we only use this once. And if we still need to find something, we can use the law of sines to finish this. Law of sines and law of cosines are used in triangles that are not right triangles, but they are used in very different situations. And the thing I like about this is that if you try and use one when you're not supposed to use it, it just like, it doesn't fit. Like you can't make it work. And I find that helpful because sometimes we're like, well, how do you know when to use it? How do you know when to do this? Like it will truly not work if you're not supposed to use it. Okay. Anybody have any questions? All right, let's put this into action, okay? So we are going to look at 5.6. We're looking at 1A. When I do law of cosines with you, I must give you side, angle, side, or I must give you 3 sides, side, side, side. So that's like another key maybe I would kind of think about. You can put it on your actual note sheet or on your identity sheet. Law of cosines, we use side, angle, side, or we use side, side, side. For law of sines, when it was a normal case, I gave you 2 angles and a 3rd side. So law of sines worked when I gave you angle, angle, side. So I had to give you 2 angles. Or when it was the ambiguous case, when we had to check a few things, that was when I gave you angle, side, side. So just something to kind of think about. As you can see, like it won't fit. If you try to use side, side, side with the law of sines, you just like can't do anything because you don't have any angles to work with. Same thing if I tried to do like my angle, angle, side in law of cosines, I just have too many angles and not enough sides to fill in. So as we do a few more of these, as we get more comfortable, like you should be able to see like which ones work where. Okay. So I'm going to do law of cosines for this first one I see because I have a side, an angle, and another side. Okay. I'm going to label the side across from 58 as little, I'll call it little a or little c, I guess, in this case. Those two go together, and it truly doesn't matter if the 10 or the 12 are my a or my b. So I'm essentially following that 3rd line. They're all the same lines, but I'm looking at the 3rd one. I don't have my side, so I'm going to do c squared equals a squared. Oh, I know what that is, 12 plus b squared. Okay, I know what that is, 10 minus 2 times a, which is 12, times b, which is 10, times cosine of 58. Okay. Any questions yet? Okay. All right, now I'm going to start simplifying. I'm going to do 12 squared, I'm going to do 10 squared, and I'm going to put all of that in my calculator because I can do all of that at the same time. I don't need my formula anymore. Oop, I do need my notes, so. Again, this is where you can play around with your calculator. If you like putting everything in, I would try putting everything in and see if you get the same answer as I do. You know, I am super careful about what I do, so I'm going to put it in one at a time. So I see 12 squared is 144. I know 10 squared is 100. And now I'm going to do 2 times 12 times 10 times cosine of 58. We've been using our calculators a lot, but I would remind you 58 is a degree. So let's make sure we're in degrees. Okay, I am. That's good. Okay, so I get 127.2. I did not include the negative in anything I did in the calculator, so I'm going to keep that minus sign there. If you want to include the negative, go right ahead. That might help clear things up later. So I currently have c squared equals 144 plus 100 minus 127.2. I'm going to combine all of those together. So I'm going to get c squared equals just one number. Again, if you wanted to put everything in at the same time, you need to see if it matches what I get right now. So 144 plus 100 minus 127.2, and I get 116.8. Okay. That's what c squares equals, and I want to equal c, so I'm going to square root both sides. And since it's already a decimal, I'm just going to leave it as that decimal. When I put in my calculator second, x squared, so square root of 116.8, and I get 10.8. Perfect. Everybody good so far? That's not too bad, is it? Okay, so c equals 10.8. Now, anybody have any questions yet? Yeah. You could technically do any of them. Yeah, well, since what we had labeled was my big C, I decided to kind of stick with that. But they're all the same. You could technically just have one of them written and use it in any circumstance. Yep, good question. Okay, so we found C. Now I need to find a big S and big H. So I'm going to do law of sines to do that because I think that's easier. And it doesn't matter which one you find first. I'm probably going to find H. And then to find S, I'll just take the two angles I have and minus them from 180. We don't have to make it any harder than it has to be. You could always do another law of cosines, but I think that that's kind of silly and kind of a waste of time. I know I'm much faster at law of sines, so I'm going to do that instead. I'm going to do sine of 58 over 10.8 equals sine of h over 10. Sine of 58 over 10.8 equals sine of h over 10. Cross multiply. 10.8 times sine of h equals 10 times sine of 58 divided by 10.8. Okay, so I get sine of h equals 0.78. Sine of h equals 0.78. Just like we've been doing kind of for 2 whole lessons so far, I'm going to do second sine to figure out what angle has a sine of 0.78. And that angle is 51.2. I don't know if you guys remember, but on the law of sine problems, when we found an angle, that was usually one of our ambiguous cases. However, that's not the case here because I know this is a triangle and I already know what 3 of the sides are. So whatever angle I get, I just get to blindly accept that angle. I don't need to check for a second triangle. I don't need to do anything else. That's my angle, and I add them all up and minus from 180 to find that missing one over here. So 180 minus 58 minus 51.2, and I get 70.8. And that is good. Okay. Any questions yet? Okay, I'm just gonna do one more. You guys ready for it? Okay. This one does not have a picture drawn, so let's draw our picture out. Anybody still looking at the one above?
So we have all
You still looking at that?
lowercase numbers. So
Hurry up.
we have all angles.
Nope, other way around. We have all sides. I have 3 sides. Side, 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 side. So label your 3 sides that way. I do not care which ones they are. Okay, I'm moving on. Oh, we've been doing this for like units. How do I find that variable? You gotta use second sine. A, we gotta pay attention, and B, that's like an old scale. I should not be talking about that anymore. CHS. And you can label it however you want it to be. 7.6. 6.4. Now this one calls for another law of cosines. The reason I know it is because I gave you 3 sides. I give you 0 angles, which means we can definitely not use law of sines. So 3 sides means that we're going to use law of cosines. And I don't mind which one you use. I'll probably use the first one just because it doesn't matter what A, B, or C is. But this time we have to find one of the missing angles. So I can find angle C or H or S. And I actually want to start, we're going to find angle H just because I feel like it. Does it truly matter? No, you could find angle S or angle C. It does not matter. Just pick one and go with it. So I'm going to do that, and I'm going to just use the first formula that I see. We'll do this. So I'll say, okay, 7.6 squared equals, I'm actually going to get rid of the calculator for now, just so you can see more of my screen. Okay, 7.6 squared equals 6 point, sorry, oh, you're helping me out?
3.2 squared plus 6.4
Perfect, does not matter which order. Good. Times cosine of which angle are we finding right now? Big H, good. This is also fairly simple to plug in your calculator, but it's different enough that I need like kind of everybody paying attention because it can get very confusing or lost very easily. Okay, so again, I'm super careful, so I like to do everything by itself. So I'm going to do my 7.6 squared, my 6.4 squared, my 3.2 squared, and then those numbers all multiplied together. I cannot do cosine of h because I don't know what h is, so I'm not going to do that in my calculator. Let me find all of these pieces, and then we'll kind of come back together and see how we can combine them. 7.6 squared is 57.76. 6.4 squared becomes 40.96. 3.2 squared is 10.24. And then 2 times 6.4 times 3.2 is 40.96. And don't forget cosine h is still attached to that. Okay. All right, what can I combine? The 40.96 and the 10.24. Can I do that with the 40?
No. The other 40.96.
Why not?
Because it's being multiplied by cosine h.
Awesome. That is a huge mistake that we often make. We as the collective kids that have ever taken pre-cal, that is a common mistake that we make. You cannot combine it because it's being attached to the cosine. So let's add these and then we're going to minus them to the other side. So I've still got my 57.76. I'm going to add 40.96 plus 10.24. And I get 51.2 minus that 40.96. Oh, I got this in. Cosine h. At this step, we usually knew we could not combine it with the 40.96, but before I let my brain even think I can combine it with that other 40.96, I'm going to minus my 51.2 from both sides. 57.76 minus 51.2 gives me 6.56 equals negative 40.96 cosine h.
And then don't we just divide by 40.96?
We divide by negative 40.96. Don't forget your negative. That can affect your answer. Remember my number, 6.56 divided by negative 40.96. So I get negative 0.16. And then like Parker told me, we're doing the inverse. So I'm going to do second cosine of that. Make that 6. Sure. And I get 99.2. Okay, that seems fine. Again, there were a few more steps with that problem than we've done in the past, but at the end of the day, it's still what we have been looking at, so nothing too crazy. Now we need to put that into my picture. 90.2, 99.2. And you can use law of sines to find one of your other angles, and then I just subtract from 180 to find the last one. Anybody questions yet? Okay, go ahead and do your law of sines. Also behind you in red, you're allowed to use that. It's just a little 4-function one. That's all you need. I'm just double checking this answer is good before I move on to do my law of sines. Yeah, 99.2 is good. Okay. Okay, I'm going to find angle S using law of sines. Okay. So sine of 99.2 over 7.6 equals sine of big S over 6.4. And then don't forget your inverse sine is how you get that angle S, at least in my case. And I get angle S equals 56.1 degrees. Your rounding may be a little different. On my paper, for some reason, I've got 60 or 56.2 degrees. That's fine either way. And then I'm going to take those numbers and minus them from 180 to get my last angle. I get 24.7. If your angles are like 0.1 or 0.01 off of mine, just let them be. That's okay. That's close enough. And if you show me enough of this work, I'll understand what you got and how. Yeah, Raven?
You said it doesn't matter like which side you put the numbers to. If you put it there.
Are you in degrees?
Yeah.
Well, we found, so the way I label mine, see how H is across from that 7.6? That means this 99.2 goes with the C. So it matters in, it does, but I labeled my 7.6. So they have to still go across each other. Easy thing to fix. Okay, that's all I want to teach today. So you have the rest of class. 5.5 is due next class. I see you. You can work on that. You can work on the extra practice. We'll do a little review before we quiz on Wednesday. I'm not in a huge rush to finish this because all I have to do is finish this 5.6, and I think I can do that in one day because I don't need to do all of these problems. So, okay, anybody have any questions? Okay, let me turn off my Zoom.